Welcome, Mrs. Mahoney's podcast. This is our second one in our Unit 5, and we're going to look at some of the bonding a little bit in more detail than what you were doing today in class, and kind of showing why we need to balance it out when we are looking specifically at the electrons. So we're at the top of page 4 in your packet, and we're going to be using these Lewis dot structures that we've been drawing to represent the valence electrons. So remember, these show valence electrons. Again, they're going to show valence electrons. How do you know that? By your periodic table. You need to have your periodic table out in front of you when we're going through these and writing compounds. Okay, sodium, where is it? Element 11, group 1. Therefore, 1 dot. And again, I could have started on the left or the right, and actually when I'm writing these, I'm probably going to kind of switch sides just to be more convenient when I'm making some of these compounds. Magnesium 2, then we go to boron 3 because we skipped the transitions. Carbon 4, nitrogen 5, oxygen, it's going to have 6, fluorine, my dots are getting messy, 7, neon, what do we know? Whoops, has that full valence. Those should actually be 2 dots. This is what it makes it stable. This is what they're looking for, that's stability. So this is the octet rule. Okay, I've added this, you need to add it. And what does the octet rule say? Compounds are going to form so that each atom will have an octet of electrons in its highest energy level. Hence octet. What does octet mean? The 8, that it's full. It's like a noble gas. This is stable, and again, that's why compounds are going to compounds are going to form is to be stable. So we're just going to draw some of this of what's kind of happening. And again, a different way of looking at what you saw today in class. So let's look at what we have first. I have a sodium ion and the chloride. Remember, the names change for the non-metals. We saw that today. So chlorine just turns into chloride when it's in a compound, when it's an ion. So what do I know? Well, sodium, neutral, has 1 dot, 1 valence electron. Chlorine has how many? 1, 2, 3, 4, 5, 6, 7, because it's a halogen. And this again, the reason I drew this was to be more convenient. I'm going to draw my singles next to the other element, because then I can show you what's happening. Well, this sodium gives up its electron to this chlorine. So what will happen then? Sodium is going to have a +1 charge because it lost it. Chlorine is now going to have all 8 electrons. Okay, I'm just going to kind of put that as an X just to show you that electron came from sodium. It's really not a different electron. We just kind of do that sometimes to represent what's happening. And chlorine has a negative charge. But when we write the compound, we take off and we'll just write NaCl. But this is why it's 1 to 1. Sodium is going to give 1, chlorine wants to take 1. It's a 1 to 1 ratio, so we show it as just a 1 to 1, no subscripts needed. Okay, what happens between then calcium and sulfur? Well, calcium is in group 2, so it has 2 electrons. Sulfur, group 6, so it has 1, 2, 3, 4, 5, 6. So it wants 2, calcium has 2. So what's going to happen? This electron is going to be given to that, and this electron can pair up over here. So they're going to pair up. What will happen then? Calcium is going to lose the 2. We say it's a +2 charge, 2 positive, +2. Sulfur then is now full. And again, what do we say? It borrowed these, stole them from calcium. -2, look at your charges. +2, -2, they balance out that net charge of 0. And what do we write it? When we write the compound, we would just write it as CaS. Again, look at the ratio, 1 of each because they balance out. Okay, this one, not quite sure what was going on there. We did it again. Nothing's going to change when we do that. So let's roll on down. Okay, so let's look at what happens if it's not nice and even. Because what do I have here? I have a potassium ion. Okay, let me get back to my pen. I have a potassium, group 1, 1 charge plus, an oxygen, 1, 2, 3, 4, 5, 6. So potassium's going, okay, I'll give you my 1. Now I'm going to be happy. But oxygen's like, wait, I'm not happy. So what are they going to do? There's going to be another potassium then that's going to have to give up its electron. So what does that mean? We get 2 potassiums. It's going to take 2 potassiums to fill up the 1 oxygen. Okay, look at the charges. +1, +1. That's a plus total of +2. -2. Your charges balance out. What's your formula? Then K2O means 2 potassiums for every 1 oxygen. Okay, I have these 3. I want you guys to finish these 3, and we'll look at them tomorrow as we get started in class using these as an example. Be patient with this bottom one. You might have to get creative with this last one. Okay, let's kind of turn the page and let's look at what I have. Excuse me, I'm going to just kind of move this over here. There we go. Let's look at the top. Let's fill in some of these notes as we go through. What does this formula really tell me? So I'm on the top of the next page. Okay, why do we write chemical formulas? Well, they tell us the types and numbers of elements in a compound. Okay, what does that subscript, the bottom number, tell you? Remember, it's looking at the ratio of atoms. It tells me how many types I needed. And the big thing when I write a formula, look at when I wrote that finished one. There was no superscript, no top number, and no charges. The reason we don't write any charges is because we've balanced out the charges. We've balanced them out, so we won't write anything with a charge. So let's look at some of these examples of what it means is happening. Okay, lithium bromide. If I break this apart, what is this made up? It's made up of a lithium ion and a bromide ion. Okay, the K2SO4 means there's 2 potassiums, and this one SO4, this is something we're going to start getting common with, but let's not stress out on this. We'll be Monday spending some more time on this. But then we could, when we're doing molar masses, remember we'd have to break this down into 1 sulfur and 4 oxygens. Okay, this is ammonium phosphate. This in the parentheses is we're going to start to recognize that this is a whole entity. It acts like an element, that this is ammonium and this is a phosphate. What's that composed of? Remember, we multiply, so there's 3 nitrogens, 12 hydrogens, 1 phosphorus, 4 oxygens. All of this makes up one compound, ammonium nitrate. Okay, I told you, language is rules, so we just have some rules and we're looking at the ionic compounds. One thing we've been looking at, you've heard me say it many times, you need to balance the charges. The net charge must be 0. Another rule when we're looking at this, you always write the positive, the cation first. You write the positive ion first. Okay, most of the time that's going to be the metal. What do you see first on the periodic table? Reading it left to right, metals. You write the metal first. So then you write the negative. The anion gets written last. Okay, so look at these examples. Sodium chloride. Sodium is first. This is just 1 sodium, 1 chloride. Okay, this is just potassium sulfide. Notice I'm ignoring the subscript when I write the name. It's just name the elements. Potassium sulfide, remembering all the negatives turn into end in IDE. Calcium bromide. I know this is made up of 1 calcium and 2 bromines, but I don't say that in the naming. I just call it calcium bromide. So I'm not using any prefixes or anything about those subscripts. Okay, so back to some properties of ionic. Remember, they're ions, plus and minus, plus and minus. That's what makes this a pretty strong compound, because they're that network. They're brittle. They only conduct when you melt them or are dissolving. We're not sharing the electrons. Now, when we write these ionic formulas, make sure that your ratio of your subscripts are in the simplest ratio. Okay, so let's start with the easy ones. We're going to start with binary. And what does bi mean? 2. So 2 compounds, we're going to make it compounds that are consisting of 2 elements. So that's just a metal and a nonmetal, since it's ionic. Metal, nonmetal. When we write these, you don't have to put a parentheses around any one of them. And again, some of these things we'll start having to use parentheses. Down the line we'll start using prefixes, so you'll kind of make sense on these. Some of these notes of why I'm telling you not to do these when we haven't done it to begin with. Okay, but again, remember, the negative element name is always changing to end in IDE. For instance, oxygen, you have this written down, becomes oxide. Phosphorus becomes phosphide. Okay, we do have this special one, peroxide, but this peroxide really only shows up with a group 1. It will only make, this only reacts with your group 1 alkali metals. So I could have a sodium peroxide, a lithium peroxide, a potassium peroxide. This is pretty rare that this peroxide is going to show up, but just know that it can kind of poke its head up sometimes. The other thing we've talked about again and again, you must have that net charge of 0. Again, balance the charges. Balance the charges. So let's just do some practice. So we're just going to name these. To name them, this is again, you need your periodic tables out. What is Na? Hopefully you know by now. That's sodium. What's O? Well, it's oxygen, but it's in a compound, so it changes to oxide, sodium oxide. Okay, Mgs. What is Mg? That is magnesium. S is sulfide. Okay, now this is the one, look at the difference here. What's the difference? Well, it's still sodium, but if I look at the charges, what's weird, because normally this is a +1 - 2 is why I need 2 of sodiums. This is a peroxide. And again, you're only going to see this with a group 1 metal show up. Okay, Al, what is that? Aluminum. N, nitrogen, but you change it to end in nitride. Okay, naming I think is the easier one, but then to write the formulas, this is where you need to balance your charges. And what I do a lot of times, until you can get to where you can do them a little easier, when I practice them, I write what the ion is above it. Potassium is a +1, chloride is a -1. So then I look at their charges, +1, -1, they balance out, so I know it's just KCl. Calcium, find it on the periodic table. It's in group 2. Since it's in group 2, that's how I know it's a +2. Oxygen is over there with a -2. So +2, -2, what happens to your charges? They balance out. You have calcium oxide. Okay, lithium. Lithium is in group 1, +1. Sulfide is a -2. Okay, they don't balance out. What do I need? I need 2 lithiums to balance out this -2. So Li, I need 2 lithiums to balance out your 1 sulfur. Strontium, group 2, +2. Bromide, a halogen, -1. Okay, so a +2 -1. Nope, they don't balance. I'm going to need 2 bromines to cancel out that. So you tell me I need 2 with your subscript. Now, some of you may have started to notice a shortcut, and we'll kind of talk about that tomorrow. And tomorrow we'll go ahead and also talk about the next page and look at some of the transition metals. But for tonight, I think this is enough, and then this is where we're going to start tomorrow. So if you don't understand, let's come with questions so that we can get to where putting our alphabet together, making our words, so these are our words in chemistry, this is something that's going to be with us the rest of the year. So let's make sure we know how to write these formulas. See you tomorrow.